Thanks for tuning in. This video is an overview of SDM, a configuration tool for RasPiOS. In this video, I'll do a quick overview of what SDM is and how it works, and then we'll jump into the demo. One quick note, I've edited out long waits from the video, but all times displayed will be correct. SDM simplifies and automates RasPiOS configuration. It has a broad set of capabilities to help you manage your Pi fleet. Using SDM, you can easily configure the network and users, install and configure applications, apply custom configuration details, configure a Wi-Fi or USB hotspot, and pretty much anything else you might want to do when you install a new RasPiOS system. Most SDM functionality is implemented via plugins. Plugins help you configure your RasPiOS system the way you want it. And if you find a need to do something for which there is no plugin, it's quick and easy to create a task-specific plugin with a bit of bash knowledge. SDM runs the customization in 3 phases as described here. This is likely more important if you write your own plugin, but I think it helps you understand how the customization process works and gives you some perspective on the console output during a customization. Every configured plugin gets called 3 times, once for each phase. The context in which the code runs for phase 0 is different than phase 1 in the post-install phase. In phase 0, the code is running in the context of the host OS and sees the image as a disk with both partitions mounted. In phase 1 and post-install phases, the code runs in the context of an image. Think of it as inside the image. SDM can be installed on Debian-compatible systems. The installer is a single command that installs SDM and all prerequisite packages. Some of the context is maintained in root access-only directories, but you don't need to type sudo. SDM handles this automatically if necessary. Let's take a quick look at running the SDM installer. Now I'll take a copy of EasySDM from /user/local/SDM, make some changes to it, and then customize an image. The first change is to the user plugin, where it will use a user list instead of inline arguments. The user list has the user configuration information in it. It's very handy for adding multiple users. I'll also set explicit localization settings and make the system journal persistent. I recommend using a persistent journal while you're getting started with SDM so you can see what happened on the first boot, for example. Now we'll customize the image. You'll see a lot of output go by. Everything that's displayed on the console is also captured in /etc/SDM/history, and all apt output is captured in apt.log in that same directory. You'll find both of these files to be extremely useful in understanding SDM. When we're happy with the customization, we'll burn the customized image to a disk. The target disk must be unmounted for burning. If the desktop file manager is configured for auto-mounting disks, you'll need to unmount the target disk first. After the actual burn is done, SDM performs a few additional configuration steps that could include expanding the root file system and running requested plugins. You'll see an example of both of these in this video. Now we'll take a quick look inside the burn disk using SDM's explore command. You'll see the apt log in SDM's history. Note that the log from burning the disk is included in SDM's history. The boot process is mostly normal, except for the SDM first boot service, which runs last during the first system boot. It will perform some last-minute configuration, including some settings that must be completed on the actual running system, such as setting the keyboard configuration and unblocking Wi-Fi. Once STM first boot completes, the system will reboot and be ready to go with all customizations complete. In case anyone watches to the end of these videos, here's some bonus discussion of a few of STM's more unique features. Thanks for watching this far. The basic idea behind STM is to enable you to easily customize your system disk exactly the way you want it, and then easily make unique copies of that for each system. STM enables you to perform each of your customizations at the right time. This can be during customization, as you customize the image disk, during disk burn, as you burn the disk that you're going to boot, after the system has fully booted, these are deferred operations that we'll talk about later, and manually on the running system, and most plugins will run that way. Fully booted means after the system reboots following the initial system boot, except with encryption, which is covered in another one of my videos. The idea is to push identical customizations to as early as possible and unique customizations to as late as possible. So, anything you want customized the same on every system, you do these during the image customization. Things that you only want done on some systems, do these when burning the boot disks. Deferred customizations are a special case of either of the above. Deferred customizations can be added during the initial customization or during the disk burn. If there are apps that you want to install, for example, but aren't needed immediately after the system boots, you can defer them to after the system first boot has completed. This helps reduce the time for customization and, perhaps more importantly, can reduce the image size, which reduces burn time, which is always a win. Some customizations are things you want done, but you may also want to minimize the time to customize the image as well as keeping the image small, so disk burns are faster. The crypt data partition encryption service uses this. With that in mind, here are some additional features you might find interesting. Of course, these are all in addition to creating users, installing apps, configuring the network, and pretty much everything else you want to do. You can create a Wi-Fi or USB hotspot with flexible configuration, or you can enable USB gadget mode, which connects to a USB hotspot. Once you've got your LabWC configuration set the way you want it, you can save and replicate it into future customizations, so all your systems show up with your desktop just the way you want it. As I mentioned, the basic idea behind STM is to enable you to easily customize your system disk exactly the way you want, and then easily make copies of that for each system. STM makes this really easy for ad hoc home users to burn a fleet exactly as you want. For instance, I use STM to create a core image and then add unique features when I burn disks. For instance, specific services, configuration, static IP addresses, etc. STM also has a module to do batch burning. These are done serially, of course, but you can have each disk burn uniquely, including unique users and pretty much anything else you want to do. STM can burn disks with GPT partition table format in addition to the standard MBR format. And on disks larger than 2 terabytes, GPT will be enabled by default, so you don't have to wait until you boot the system to wonder where all that extra disk space went. STM makes it easy to use BTRFS on your root file system. When burning, STM can extend the rootfs a specific amount and add a large partition following it, making it simple to use a separate home partition, for example. And STM separately enables an encrypted rootfs and or encrypted data partitions created using the large partition I just mentioned. STM makes it easy to install and configure complex services such as Samba, DHCP, DNS, Cronny, sync thing, VPNs, and of course, PyApps. That's it for this SDM overview. I hope it has piqued your interest in SDM. If you have any questions, please don't hesitate to head over to the SDM GitHub and open an issue or a discussion topic there. I'm happy to help you get started and be successful with SDM. https://github.com/gitbls/SDM.